Welcome. In this video, I'm going to go over how to apply the root test to determine whether an infinite series converges or diverges. So before I get into the weeds here, let's just recall what is the root test. Well, with the root test, we want to look at the limit as n approaches infinity of the nth root of the absolute value of our infinite series. We're going to call this L, and frankly, I could have called it anything. I could have called it heart. I could have called it cat. But most textbooks call it L, so I'm going to call it L. If L is less than 1, then the series converges. If L is greater than 1, then the series diverges. If L is equal to 1, then this test is inconclusive. Okay, so we have our little aside right there, recalling the root test. And now, let's apply it. Well, the a sub n term, the nth term, that's 4n squared plus 1 divided by 5n squared minus 8 to the nth power. And the limit as n approaches infinity of the nth root of this, well, that's equal to the limit as n approaches infinity of 4n squared plus 1 over 5n squared minus 8. Now, this is one of those classic Calc 1 limits that you've probably seen when you were looking at limits at infinity. And if you don't recognize it, notice that each of these has an n squared term, the leading coefficient that is. So we can just factor that out to end up with 4 plus 1 over n squared over 5 minus 8 over n squared. As n grows large, these fractions become 0, and we end up with 4/5. This is certainly less than 1. So what does this tell us? This tells us that this series converges absolutely by the root test. All right, folks, hope you're having a good day.